Okay, guys, I think now it's okay. So, guys, we're gonna do Euclidean. So, I'm gonna teach you something. Today, I'm gonna say it's part one, ne? Then part two, we're gonna finish whatever we won't be able to finish today, and we do some questions. I feel like it's very important if I do questions with you, just to check your understanding. Because sometimes you guys come to class, you just look at me writing stuff, and you understand for that moment, then you don't practice, you don't do questions. Then a week later, you forgot almost everything that we did in class. So I want to emphasize on how important it is to do something after class just to make sure that you're familiar with whatever we just did and you mastered everything. So guys, Euclidean takes about, yeah, but it's a lot of percentage in your paper two final exam. So it's very crucial for you to understand everything we do. Ne? So now I'm just gonna go back to my screen. So now, guys, this lesson is for both grade 11 and grade 12. So you guys will be collaborating. And for the physics topics like Newton's laws, metal materials, acids and bases, when I hold such classes for those topics, you guys will be mixing, you guys will be together in one class. So now, like I said, this class is for Euclidean geometry. By the way, the geometry part reminds me, the next class we're gonna have, the next combined class is gonna be for analytical geometry. So I hope you guys are gonna show up to that one too. So now, when it comes to Euclidean geometry, remember I said today we're gonna be doing cycle geometry, meaning our geometry will be evolving around circles. So there'll be a lot of things happening in the cycle. So now, with this cycle geometry, there are a lot of, they formulated what you call theorems to describe the behavior of angles and some of the properties of a cycle. So you guys know what a cycle is. There's no need to define a cycle. Everyone knows how a cycle looks like. So guys, you have couple of theorems like I just explained to you right now that are explaining the behavior of angles, relating everything that happens in the circle, all the properties, which is something we're gonna start with. But now, when it comes to our theorems, I'm not interested in knowing what's theorem one, what's theorem two, what's theorem three. That's not gonna help you in the test or exam. They're not gonna ask you which theorem, what does theorem one says. You just need to know the theorems by heart. But this is what I know. Some of those theorems, they speak about the center of the circle. So it means in some of those theorems, we have theorems that are focusing only on the center of the circle, nothing else but the center. The theorems evolved from the center. So now, I know that there are theorems that speaks about something called a tangent. Okay, what is a tangent? Don't worry, you're gonna know what's a tangent soon. Now, I know that I have theorems that speaks about a certain quadrilateral. Remember, a quadrilateral is a four-sided figure, meaning if you have a figure and it has four sides, it qualifies to be called a quadrilateral. But now, when we have a quadrilateral inside the cycle, we call it a cyclic quadrilateral. Why the cyclic part? Because it's inside the cycle. But not every quadrilateral that is inside the circle, it's called a cyclic quadrilateral. It must have certain properties, which is one of the theorems that you're going to be doing. So now I know what some of my theorems will be focusing on this guy called a cyclic quadrilateral. But guys, you know that in maths we are lazy. So I'm not going to write quadrilateral. We just say quad and it's done. So now before we look at all these theorems, there are few things that you need to understand first. Now, let me write here and say keyword. Then I'm gonna write subtend. Is this A or E? I think it's E. Subtend. This is a keyword. You're gonna be using this word often. What does subtend mean? Before I explain what does subtend mean, let's look at the circle as a whole. And just look at all these properties inside the circle. There are 90 here. I was doing something else. Let me try to erase. I'll be erasing as we go on. I forgot to start a new document. I apologize, guys. So I'm just gonna draw a circle very quick. So let me try to insert a circle instead of drawing it, because if I draw it, it's gonna be a mess. Shapes, and where's the circle? I can't find the circle here. Circle, where are you guys? You know what? Let's forget about inserting shapes. Let me just draw the circle. The sketch is ugly, guys, but in maths, this is not EGD. We don't mark, they don't mark your line work or whatever. So now I'm just gonna draw a circle. Okay, it's not big enough. It must be big so that whatever I want to explain fits. So I'm just gonna draw a circle. So guys, I'm just gonna try to avoid all the fancy math language. So now, here at the rim of a circle, or should I say at the edge, here, this part around the circle, you know that you call this a circumference. So meaning the circumference is just at this black line that is going around. You see this black line going around, that area, we call it a circumference. Ne? So now, inside the circle, somewhere here right in the middle, we have a point called the center. So usually we name the point O. It doesn't mean the center is always named O. I say usually we name it O. So I'm just gonna name it O for now. So sometimes they'll name your center M and someone is like, nah, it's not the center because they didn't name it O. Guys, I'm just saying most of the times they name your center O. So the center is just right there in the middle, like right there. Guys, in the test, when you write Euclidean geometry, you need to read your statement. If in the statement they didn't specify or give any property that might give you or that might lead you to the direction of concluding that whatever they do that looks like it's in the middle, it's a center. If they didn't say it's a center, it's not a center. Meaning if there is no center, the theorems that are about the center, they're out. You can't use them if there is no center. So if I draw a line from one point at the circumference, I just explained, or this black line going around here, this is at the circumference. Or if I'm sitting here, we are at the circumference. Now, if I draw a line from one point of the circumference all the way to the other point of the circumference, we give this line a name. We call it a chord. But listen carefully. If I draw a line from one point of the circumference to somewhere in the middle, this is not a chord. It's just a random line. You must listen carefully to how I explain everything so that you don't forget. Okay, it's erased. So that you don't forget. A chord has to be a line drawn from one point of the circumference to another point of the circumference, meaning my chord can move from this point to all the way there. Now I check. Does it move from one point of the circumference to the other point of the circumference? Yes, it does. So it qualifies to be called a chord. That's a chord. Let me remove the second line. So now, usually, we name our chords so that you can use them. So you can say the starting point, this side it's A, then to the other point of the circumference, where is the ending point, I can just call it B. So now this is gonna be called chord AB. Right. You can call it chord BA, no problem. So, okay, now you know what the chord is. Let's look at other lines that can be drawn inside the circle. If I draw a line from the center, keyword, from the center, not just anywhere, guys, not from where you feel like drawing it, and not from your favorite point, from the center. You draw a line from the center to the point of the circumference. This line, since it's drawn from the center to the point of the circumference, has a special name. We call this guy radius. You must be careful. Okay, let me admit someone to the call. Give me a second. So the line is drawn from the center to the circumference is called a radius. Remember. So now let me use another color for another line. Okay, fine. So now let me erase this name here for now. I named it O, remember. So now what if we draw a line from the circumference and the line goes through the center to the other point of the circumference? Okay, guys. We agree this is a chord because remember, what are the properties of a chord? A chord has to run from one point of the circumference to another point of the circumference. So the red line, guys, yes, it checks out, but now it's special. Why is it special? Because it passes through our center. Remember, we specified our center. That's how we got our radius, because remember, a radius has to be drawn from the center to the circumference. Now, we have a line. It's not drawn from the center, but it's drawn from one point of the circumference. It passes through the center to the other point of the circumference. Now, what do we call this line? It's a chord. Yes, yes, yes. I see you. You say it's a chord. You are right. It is a chord. But since it passes at the center, it's a special chord. We call this guy diameter. This special chord, we call it diameter. So now, this diameter guy and the radius, they both passes through the center. But you already saw something. You realize what that from the point of the circumference to the radius, to the center, to the center, this part is a radius. From the center to another point of the circumference, it's another radius. Oh, it means diameter. It's actually r plus r. It's r twice, r plus r. So it's r twice. It's two r's connected together to form a straight line. They form a diameter. Are we together, guys? So let me just erase this part. Now we got the diameter, the lines out of the way. So I can erase my radius and my chord. I want to leave this diameter. So now this is what I'm gonna do. I'm gonna use blue. Let me color this part with blue. Blue, 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 blue. Blue. Then I'm gonna color another part with maybe orange. So now you can see, guys, if you look at this, your diameter divides your circle into two parts, the blue part and the orange part. Now the question, what do we call these parts? Do we just call them parts? Do we call them pieces? Do you call them Shidu sisters? I have no idea what do you call them. Okay. Now, guys, let me go back to my black pen. Now, guys, we're gonna learn a new property about a diameter. Okay, not a property, but something it does, something useful. So now we're gonna say our diameter divides a circle into parts. With the blue part and the orange part, we're gonna call them divides a circle into, now we get a new word, segments. Segments. So when we say segment, we talk about these parts. Now, a diameter, it's a chord. Oh, it means every chord can actually divide a circle into segments. Okay, so let me draw a smaller circle here. So if I have a little chord here, what it's gonna divide this circle into 1 and 2 here, 2 segments. 2 being a bigger segment and 1 being a smaller segment. Guys, so far, do we understand? I want to erase. Okay, let me just move.
Yes, sir.
Can everyone confirm when I ask if you guys understand? Hey guys, there is a lot of engineering stuff here. I was in engineering class, you'll forgive me.
Go through it again once more.
Let me erase. Everyone so far is happy.
Sir, can you please repeat it one more time?
I don't know if... Shall I repeat what?
One more time. Repeat the segment.
The segment. Okay, no problem, sis. I'll just erase here. Give me a second. Let me erase here. Okay. Okay, let me just draw another circle. A quickinyana circle. A quickinyana circle here. A retinyana circle. It's a circle. Okay, let's start here. Do you understand the definition of a chord and a special chord diameter? Okay, let me not speak about diameter because it's just a chord, a special one. Let me just say a chord to generalize everything. Do you understand the definition of a chord?
Yes, sir.
What's a chord? A line drawn from one point of the circumference all the way to the other point of the circumference. Drawn from one point all the way to the other point of the circumference. Are we together? So,
Yes.
do you notice something that the chord does to the circle? When I ask you, answer with yes or no. Do you agree that this chord divided our circle into two parts?
Yes.
Okay. Those two parts, they are the ones that are being called segments. So what are here we have? A segment here and a segment here. What are we have? Two segments. So what does it mean? If I draw another chord, let's say it moves from the very same point to another point of the circumference. Now my chords divided my circle into three segments. So now I have a third segment here. Those parts that the chord is dividing the circle into. So do you now know what the segment is?
Yes, sir.
Okay, perfect. Let me erase this one. I'm gonna draw another circle. Okay, let me use my black pen. Let me draw another circle. When I draw a circle, when I draw a circle, I'm gonna bring back my, okay, let me not bring back my center for now. So I'm just gonna draw two chords from the point of the circumference to another, from the point of the circumference to another. Okay, no, actually, guys, let me do this. Let me speak about, let me use a chord. I mean, a chord, one chord. Let me draw one chord. Okay, guys, my chord divide. Okay, let me name this guy AB. Guys, my chord AB, we agree it divides my circle into two segments. We check that point out. Also, guys, it doesn't only divide my circle, it divides the circumference. Are you aware? Are you aware or now it's cutting the circumference here and here at point A and B? Vumanivo.
Yes. Yes.
Thank you. So, so it divides my chord into my circumference into these little guy here, the red guy. Remember what the circumference is the whole black thing, like the whole black line around, which makes up the whole circle. That black line is it's at that place we call it the circumference. But now when I draw a chord, it divides my circumference. I'm gonna say that's the first guy. Now I'm gonna use the blue guy to show it divides again into the blue guy. So now what do I call that red guy? It's no longer a circumference because it's no longer complete. Ne? So it's no longer circumference. What do we call the Sana? What are you doing? The red guy and the blue guy are called the arcs. So we have a red arc and we have a blue arc. Perfect. Are we together, guys? So now we understood everything. This terminology. Guys, did we get it? We can move on.
Yes, sir.
Okay, perfect.
Yes, sir.
So remember up there, guys, I said something like we have theorems that are speaking about something called an arc. An arc. So what is this arc? An arc, by definition, it's a line drawn outside the circle. Now, number one, key important part about this tangent. Did I say an arc? Yeah. Okay. Tangent. I said that some of the theorems are gonna be speaking about some guy called a tangent. So now let's define a tangent. A tangent is a line. Now, key points. You have to listen attentively. Number one, it has to be drawn outside the circle. Number two, it has to touch a circle at only one point. If that line touches a circle at more than 1 point, maybe 2 points, it's a different thing. That's when we're gonna have lines like seconds, but we're gonna speak about them later, no problem. So what is drawn outside the circle? Why do I have a box there? Why do I have a box there? Okay, my tangent line is drawn outside the circle, touches the circle outside at just 1 point. So it's only this point I'm gonna call it point A. That's the only place where the tangent touches a circle, at one point and outside the circle, not inside, outside. Someone, you're gonna have a line crossing like this. Guys, that's not a tangent. It has to be outside the circle and touches the circle at only one point. Guys, can you move on?
Yes, sir.
Okay. So now, let's go back to our keyword, which is subtending. After subtending, we go straight to looking at what our theorem says. Our theorems say, starting with the theorems that are speaking about our guy, which is the center. Center of attention. What the fee for shining. Never rest the eyelid. No man can time this. The vibes are endless and timeless. In a city where you will define it. Like the way I live and I redefine it. Oh, Nasty is so good. How can an artist be so good? Don't say anything. Don't say anything. Not this is good. Guys, I'm your tutor right now. Whatever the tutor says, you just agree because they're teaching you. If I say I'm a woman, you agree. Don't say, Everything I say right now in this session is correct. I'm in charge. How? If I say we're in USA right now, you agree. If I say we put sugar inside amas, you agree. But that one is actually like that. We put sugar inside amas. Okay, let's go back to our keyword. Please don't say anything. I'm a tutor. What I said is final. Next, this is the greatest artist in the whole.
So let's continue.
Sissy, I'm gonna remove you from my session. What I say goes. It's done. The pen I'm writing with right now is orange. If you say black, you're out. Mozo, when you know better than me.
For telling the truth, Harisa control. Harisa control.
Okay, guys. So now you're gonna see the word subtend. What does subtending mean? When you say chord AB subtend an angle, we mean there is a line drawn from one end to somewhere, I don't know where, maybe here. And from the other end, there is another line drawn. But now, these lines, guys, they meet at a certain point, common point. So these two lines are drawn from both ends of the chord to the certain point, to the same point, to the common point. When they meet there, they form a certain angle. I'm gonna name it X. Oh, so now we can say chord AB subtends angle X. Are we fine? Let me draw another line from the end, which is A, from the end of the chord, maybe to the circumference, and a line drawn from another end, which is at B, to the common point as the first line. Let's say this is B. Again, AB, chord AB. When I say AB, guys, just know I refer to chord AB, subtends B. Or we can say it makes that angle. We can say it holds the wings. Yeah, it holds the wings that make the angle. So guys, do we get the subtend part?
Can you please repeat the subtend?
I'm saying to you, okay, let me redraw the things from start, because if I explain what the things are drawn already, you won't understand. Okay, I'm saying I draw my chord AB. Ne? Remember the chord drawn from one point of the circumference to the other point of the circumference. That's my chord AB. Ne? So this guy AB, from he has the beginning and the end, the start and the finish, from A to B or from B to A. It has two ends. This chord, it has two ends. The first end being A, the second end being B. So now if I draw the line from A, let me start with A. If I draw the line from A to somewhere inside the circle or outside, it doesn't matter. But let's say I draw from A to somewhere there. Then I draw another line from the other end, which is B. Now it meets the first line at the common point like this. So you see where they meet, we are saying they're gonna make an angle. I'm gonna say X. Since both these lines that are making the angle are drawn from both ends of the chord, we are saying therefore the chord subtends this angle, which is x. Is it fine now?
Yes, sir.
Then I'm saying, okay, let me use a different color for another wings. The Red Bull give you wings. So from A, again, from this end, let's say to somewhere, maybe let's say the circumference. Then from the other end, which is at B, to maybe at the which is at the same common point from to where the first line went to where the first line went to, yes. So I'm gonna name this angle B. So now we can say chord AB subtends angle B. Are we together? So you understand what does it means when they say the chord subtends an angle?
Yes, sir.
Yes,
Does it?
sir.
So everyone knows, ne? So it means, guys, if we have a situation, okay, I thought I'm erasing. So if we have this situation, I was not supposed to erase my chord, but it's okay. Let me change my ink back to black, back to black, back to black. So I'm just gonna say this is my chord. I'm gonna have this. So guys, we agree that AB still subtends angle X, ne? Guys, do we still agree that chord AB subtends angle X?
No.
Yes, no. Why?
The angle x, at x, the only chord, at x.
Okay, it's okay. Take your time. Let's go. Who's
Okay,
speaking?
so
I can't,
one.
guys, I can't see your names because now I'm here writing, so I have to go back to that tab. Yeah. So just tell me your name before you speak. Who's speaking?
One.
Okay. Ore, what up? Oh, yeah, yeah. I see that you see what's going on. I want you to be able to explain it. Keep going.
So what you said, when an angle is subtended, it means that it is formed by two lines from each of the point of the chords. So in this point, in this case, the chord is AB, and only one line is from point B, and then the other one is not from the other end, which is point A. So this means that chord AB does not subtend angle X.
Yes. So basically, you can see where this line does not come from the other end. It just comes from where it wants to, like somewhere here, like in the middle or something. So we can't say AB subtends angle X. So yeah. So now, guys, not only chords can subtend angles, even arcs. Remember, I told you what an arc is. Let's say, let me erase the ABs. Let's say a line comes from here to somewhere here, another line comes from somewhere here, and it meets this line at a common point. Let's name that angle maybe alpha. Okay, let me increase the thickness of this alpha. So this, okay, let me highlight the different cut. You can see, guys, same thing with the chord. Same thing with the chord. I'm just gonna highlight this arc, the blue arc. Are you aware that these lines that are making this angle, these lines that are meeting at the common spot here to form an angle A, they're drawn from the points of a certain arc. Are you aware, or we can say, if I name this AB, this arc, are you aware that arc AB subtends A? Same with the chords, guys. Are you aware, guys? Little sisters, are you aware?
Yes, sir.
Yes.
Okay, so now let me do something like this now. By the way, guys, arcs are not usually named. It's only chords. So you just have to see that, oh, it's subtended by an arc. For example, let me draw another circle. You can have a random thing like this. You know, or if it's angle B, can you see where this angle B is subtended by an arc?
Yes.
Okay, but okay. Let me not say but. Let me not say but. I'm just wanna see something from you. Let me draw another. Let me draw another circle. So this one, let me say this is x again. So x is subtended by an arc, ne? Guys, is x subtended by an arc?
No, sir.
Perfect. Because there's no arc. There's no arc here unless I stretch this out until the circumference. Now we have an arc, which is this guy here. Which is this guy here. It's an arc that subtends this angle. Okay, guys, now we can move. A lot of engineering stuff. Sorry, guys. Ish. Let me try to erase. My rubber doesn't like me today. Okay, I don't know what's going on here. Yo, I don't know what's going on. Give me a minute. The PC I'm using lately is disappointing me. I don't know what's wrong with this computer. But God knows, and God is with us all the time. Hallelujah. Hallelujah, guys. How? Guys, hallelujah.
Amen.
Amen, amen. uNkulunkulu sithanda sonke. I'm erasing, give me a second. God loves us all. 17.32 amperes. Conje, guys, what do we measure? What do we use? What is it that is measured in amperes?
Current.
I don't trust you guys. Someone is saying power. I hear, and it's probably some.
Excuse you. That's why I send you a picture how
No, noise.
I'm against you
That's why
now.
we really.
Ba send you a picture how mo le mo groupung.
You know, Fenze. Na Fenze, I don't know, guys. Fenze.
Are le nna ke tla mo joina. We'll defeat
That's
you
why.
together.
That's why you are disowned, Fenze. No longer brother and sister. Fenze is just one of my learners. Just like you, Sambo, you're one of my learners now. So,
Oh, you're also one of my tutors now.
yes, Sekel. Why am I writing Sekel? How? I wanted to write centers. Okay. So now, let's talk about the theorems that involve the center. So we can address all the theorems about the center before we move to other theorems like your cyclic quadrilateral and your tangent. So now, what does the first theorem that talks about the center say? So I'm just gonna draw my circle. Ne? So when I drew my circle, I'm just gonna draw a line. Then I'm gonna name the line AB. Konja, what's the name of my line AB, guys?
Chord.
Chord. Yes, chord. So here I'm gonna have my center O. So what does the first theorem say? The first theorem under the center category. It says the line drawn from the center, guys, there has to be a center. Number one, there has to be a center. If there is no center, whatever theorem you're doing here doesn't exist for that particular problem you're trying to save. The line drawn from the center, it says, it says the line drawn from the center of a circle is perpendicular to the chord. That's it. Guys, that's a statement. That's a statement. So now we have to prove something under this theorem. Okay, what does the statement say? In your Euclidean geometry, you have what you call statements. You have to, then there are statements. Then from the statement, you have to prove that whatever it is, there is a conclusion that you need to prove. So meaning there is a statement made. From that statement, you need to prove the conclusion before you conclude. So now, the statement for sure, the statement says line drawn from the center is, I'm just gonna use this perpendicular to the chord. Guys, you can use this to show perpendicularity. Ne? Just write this side to the chord. Okay, guys, we have your statement. But now, okay, from this statement, what is it that we should do with the statement? Is it just a statement we are writing in JS do people just to make ourselves happy? No. From the statement, there is something that we need to prove, a conclusion that, okay, since it's perpendicular to the chord, it bisects the chord. So I'm just gonna underline this with red. We are not sure yet. We are not sure yet, guys. So now we have our statement. The line drawn from the center is perpendicular to the chord. Okay, for this theorem, what are the things that you need to be aware of? Number one, there has to be a center. Perfect. Hence is the theorem under the center category. Okay, there has to be a chord somewhere. Guys, a chord doesn't have to always be here. It can be here. And there is a line drawn from the center to the chord. And that line we are saying is perpendicular to the chord. So don't be confused, guys. Just know the chord can be anywhere. So when you are writing, guys, as a Shidu, as someone from Shidu, you must show, man, or you know your stuff. So, okay, let me just do this on the center. Let me draw bold a bit. Okay, guys. So now we need to prove that indeed the line drawn from the center perpendicular to the chord bisect the chord. Okay, what are the things that we need to be aware of when we are solving Euclidean questions? When we'll be solving questions, it means, guys, if there is a line drawn from the center to the chord, it's always gonna be perpendicular to the chord. Are we together? All the time, guys, all the time. But let's prove that it also bisects the chord. Now, this is how you prove, guys. Your proofs must be neat. It must be neat. Given. What is it that you're given? Can anyone tell me what's given? Okay, now I say we're given center O. What else? What is it that we're given, guys? Come on, look at what is it that we're given? We are given center O. What else are we given?
That a chord is perpendicular to a tangent.
Thank you. A chord is perpendicular to the tangent. But now, did you say a tangent? A chord is a radius. No, not the radius. A line drawn from this center to the chord is perpendicular to this chord. You
Sorry,
said
it
a
was a
tangent.
mistake.
Now you're confusing
Sorry.
me, man. So this
No,
point,
it was a mistake.
wait. Now this point where this line from the center and the chord meet, I'm just gonna name it M. So what you're trying to say, or we're given that OM is perpendicular to chord AB, OM being the line drawn from the center. These are the things that we were given. So now you are required to prove this conclusion that I underlined with red. So required to prove. Konje, what are we required to prove from this? What does bisect mean, guys? When you hear the word bisect, what does it mean?
To cut into two equal halves. So what we are required to prove is that AM is equals to BM.
Yes. So when they say something bisects something, it means it cut it in equal parts. So guys, from now on, I want to hear your English different. At home, I want to hear you saying, Mama, let's bisect the cheese. You'll be homeless. I'm joking. So AM is equals to MB. Guys, AM is not equals to MB yet. We are still required to prove. So when you prove, guys, when you are done writing this down, you need to come to something called construction. So you need to perform what they call construction. Guys, there is a mark for construction when you're proving in an exam or a test. They give you a mark for construction. Don't forget. So we need to construct radii. Guys, radii is a plural form of a radius. Where do you construct your radius first? Which is wrong. You must say radii. That's a plural form. You need to construct. So you need to complete right-angled triangles. So you need to construct the first radii here. And when you construct, guys, you use dotted lines. Here, that's not straight. That's not straight. That's not straight. Okay. So, manje, my line is gone. Kanjani, bro. It was supposed to be like this. If this is 90, this is also 90. Angles on a straight line, you know that, ne? So I want to use a different ink for my. You need to construct these two radius when you prove this theorem and construct this. Then you get a mark for that. What up, guys? When you're proving theorems in your script, you need to redraw the circle. You need to redraw the diagram. Then you do your construction. They're gonna give you a mark for that. Are we together, guys?
Yes, sir.
Okay, let me get rid of the 10 ohm resistor here. It's blocking my Euclidean. Now we continue. So now, how can you prove this? We have two triangles, two right angle triangles. Oh, I can use congruency. Guys, do you still remember congruency? So now you can say prove. Since I have two right angle triangles, I can use congruency to prove that AM is indeed equals to MB. Guys, do you remember congruency? So when you do congruence, remember from grade 10, you start by saying in triangle. Which triangles, guys, are we going to work with? The triangle. So the two triangles that we choose, there has to be a triangle where there is AM and there has to be a triangle where there is MB, because we are trying to prove that AM is indeed equals to MB. So which two triangles are we going to work with, guys?
AMO and triangle BMO.
And triangle AMO, you are right. Can someone tell me the another triangle?
Triangle AOB.
Triangle
AOB.
AOB. Guys, remember that we are trying to prove that AM is equals to MB. Because remember, I can always say the line drawn from the center to the chord is perpendicular to the chord. But now we need to prove that when that line is perpendicular to the chord, it also bisects the chord, meaning it's dividing the chord into two equal parts. Those parts are AM and MB. So we must prove that AM equals to MB. Since we did construction, when you do the theorem, you do a construction of these two lines, which are radii. Remember, they are lines drawn from the center to the circumference. So we can call each line a radius. So now, we see that this makes two right-angled triangles. Our construction results in two right-angled triangles. So now, since we have two right-angled triangles, the best way to prove that AM equals to MB is to use what we call congruency. So congruency, we need to use two triangles. But since we're trying to prove that AM is equals to MB, in those triangles, I must have AM in one triangle and MB in another triangle. So one sister said we can use AOM. I agree. Triangle AOM is going to work because AM is there, first part. So the second triangle you choose, there must be MB. Which triangle is that?
BMO.
BMO. BMO. So let me just say, yes, it's BMO. Now we prove. So do you remember the conditions for congruency? You must have a side, included angle, and a side. Side. What else? Right angle, hypotenuse, and a side. All those conditions, you know them because you did it last year. So now, this time, guys, from the first triangle, I have OM. Second triangle, I still have OM. Are you aware, guys? Are you aware that the two triangles, they share OM?
Yes.
So you can say OM is equals to OM because this is a common side. By the way, guys, this proof, you're going to do it like this. If they ask you to prove, you're going to do it like this. Your whole grade 12 or grade 11, yes, you're going to do it like this, guys. It's not going to change. So if you understand from what I'm doing right now, you know how to do one proof, one problem out of the way. OM, so it's always going to be like this. Oh, so if they didn't name this side where this line intersect with the chord, you can just name it S for Sana. Come on, guys, I'm your brother. You must honor me. So then you do your constructions.
Example,
Guys,
guys.
what?
S for Sambo, not Sana. No.
O thoma ye nngwe bjane follow re taba eo. So constructions, guys, are being done with these dashed lines. So you don't make solid lines for construction. You make these dashed lines. Don't forget that. Okay, OM and OM is a common side. Remember, we need two more conditions. Congruencies must be three conditions. We proved one condition, two more to go. Excuse. Are you aware that OA and OB are equal? Because these are OA is a radius, OB is a radius. They are the radius of the same cycle, so they must be equal. Are we together, guys?
Yes.
Yes, sir.
So your reason must be, well, radi. Why do I write radi? Remember, it's a plural for radius. There's no such a thing as radiuses. If you want to behave, you can write radiuses in your script to get 0. But if you want to satisfy your heart by saying, nah, it's supposed to be radiuses, you can write it. You'll get 0, but at least your heart will be satisfied. And I hope the failing maths will also satisfy your heart. So, guys, can I say AM is equals to MB so that my condition is SSS? No, because I'm still trying to prove that AM is equals to MB. So, or I must use something else. Now, let me go back to my diagram. Guys, are you aware that O angle MA is equals to O angle MB? They are both equals to 90 degrees.
Yes.
Guys, do you know how
Yes.
to reference these angles like this? Like OMA. Or I'm referring to the angle in OMA. You follow OMA. Or is this angle? OMB is this angle. Does everybody know how to reference the angles like this? Let me go back to the session. Guys, does everybody know how to reference angles like that?
Yes, sir.
Oh, so everyone knows how to reference angles like that.
Yes.
Okay, perfect. Now let me continue. Guys, there we go. We just proved the 3 conditions for congruency. Guys, conditions for congruency, if you don't know them, you'll have to attend my session with grade 10s when I teach them maths. When I teach them, if you forgot the conditions. Or maybe I'm just gonna do them as a quick recap. Mara, I expect every grade 12 learner to know them. Okay, guys. Therefore, since we proved 3 conditions, we can conclude that triangle, was it? AMO is congruent. Remember, for congruency, we use this sign. You remember this sign, eh? Is indeed congruent to triangle OBM. What's your reason? Right angle, hypotenuse, and a side. A side here is a common side. The hypotenuse was the radii. If you can check your right angle triangles there, that radii represents your hypotenuse side, which is your longest side on the right angle triangle. The R part is the right angle. We got it 90 degrees. So it checks out. Therefore, since the triangles are congruency, you can conclude now. Let's go back. You can conclude that indeed AM is equal to MB. But why are they equal? You just write from congruency. Was the proof of this theorem hard, guys? Was it hard? Was it difficult? Was it draining? How was it? Was it okay? Did everyone get the theorem?
Yes.
So
Yes.
any day you can, guys, it's not gonna change. It's always gonna be right angle, hypotenuse, and the side. It's never gonna change. So, guys, any day you can be able to prove this theorem, any day given. But if they wake you up in the middle of the night, they say, prove us this theorem that says a line drawn from the center to the chord is perpendicular to the chord and it bisects the chord. You can be able to remember the bisect the chord part was the conclusion we are trying to prove. So when they say prove this conclusion, that indeed the line drawn from the center of the circle to the chord and that line which is perpendicular to the chord is indeed bisecting the chord. Can you prove this conclusion any time of the day given?
Yes.
Why is it only yes? One yes.
Yes, sir.
Ah, okay.
Yes, sir.
Guys,
Yes,
do you
sir.
need this PDF? Guys, do you need this PDF at the end of the session?
Yes.
Ay, sakahlangene la. Ay, because I've been erasing things, so I'm on. And I wanna tell my engineering things at the bottom here, but it's okay. Let me go back to drawing. So now, what's tiring? Okay, not tiring. What's draining about this theorem? It has something called a convex theorem. What the converse mean? Okay, let me not explain it mathematically using those terrifying math terms. So a converse, when Sana is hungry, he fights with people. Whoa, it's a theorem. What will the converse say? When Sana fights with people, it means he's hungry. Okay, guys, do you get the idea?
Yes, sir.
Yes, sir.
When Sana is hungry, he fights people. So what's the converse? When Sana is fighting people, he's hungry. Guys, are we together?
Yes.
So you guys now get the term of a converse. Okay. So what does the converse say? Now let's draw the circle again. Now I'm gonna draw my chord AB. Oh. Then from here to here. Why am I writing AB at the one side? Hey guys, we are old right now. I qualify for that old people pension because wow, I've been seeing things small fatting. I lived during those eras when our Desmond Tutu they were still 20. By the way, we are not there. Okay, so now conversely, let me name this M. Conversely, guys, we know that AM is equals to MB. Then when you go backwards, what does it mean? Guys, now we're going backwards. I think we had okay. Let me not tell you what we had before to see if you remember the theorem we just did seconds ago. Guys, this time for sure, 100%. We know that AM is equals to MB. Then what does it mean when we go
It
backwards?
means that OM is perpendicular to
Thank you.
AB.
We go backwards. It means OM is perpendicular to AB. Remember, the theorem was saying OM is perpendicular to AB. Then prove that it bisects AB, or I'll prove that AM is equal to MB. So now on the converse, we are saying AM is MB. We know that for sure. What does it mean? We go backwards. It means OM is perpendicular to AB. Are we fine, guys? Is everybody okay?
Yes.
Okay, fine. Let me raise this. Okay, guys, after center theorems, I'm gonna end the session. Then we're gonna do tangent theorems. Then we're gonna do I think tangents is slightly quite because you know what took time is explaining the circle, what does the lines mean, and all of that. So after the circle, then tomorrow, guys, I'm gonna do another session for the tangent and the cyclic quad. So I'm gonna call this part 1. Yes, I'm gonna upload it to so people have trouble accessing my drive. So I'm just gonna put it on YouTube so you guys can just get it there whenever you want. Ne? So there'll be a folder under our channel, Sana's recorded, because now it's only Andisa and yeah, she'll forgive me. Andiswa. There's only Andiswa's recorded sessions. So Andisa will be teaching grade 11's physics. Then I'll be teaching grade 11's chemistry. So she'll teach physics, I teach chemistry for both grade 11 and 10. As for grade 12, guys, we don't have any arrangement with you. Okay, now we go to the another theorem that involves the center. Let me just call this number 2. What does the second theorem that involves the center say? we are saying if this is a circle, I'm just gonna draw my circle. Remember, we are still in the center theorems. So I'm gonna have my center here. I'm gonna name this guy center O. So let me draw my chord. I'm gonna draw my chord. I'm gonna name my chord A, B. Ne? So I'm just gonna do this. So I'm gonna name this guy angle beta. Konje, what's the relationship between chord A, B, and beta? Yeah. Chord AB subtends B, beta, subtends angle beta. Where does it subtends it when you are checking? Where does it subtend it, guys? Where at the circumference, at the center? Where is AB subtending angle beta?
Not at the center.
Eh?
Not at the center.
At the center, ne?
No.
Yes. Okay, this guy called AB subtends our angle beta at the center. So now let's okay. Yeah, it's at the center because here it's center O. So these two wings from the ends of the chord AB, they meet up at the center to make the angle beta, meaning they subtend angle beta at the center. Are we fine?
Yeah, man.
Yeah. Are we fine?
Yes.
Are we fine? Okay, so now let me draw another wings or another lines from the ends of the chord or another angle to be subtended. But this time, I'm gonna take this guy all to the circumference, and from this other end, another line to join that one, so that my chord can subtend another angle at the circumference. Okay, let's check. I have my chord AB. Okay, guys, by the way, this is the same situation like this. I want you to get used to this. My circle is ugly, but no problem. This is my center. I have an angle subtended by an arc, not by a chord. So this is just the same thing, guys. Ne? Don't be confused. Whether it's an arc or a chord, it's the same thing. Beta here, alpha. So it's the same thing, guys. Are you aware? But this time it's just these angles are subtended by an arc. This time they're subtended by a chord. It's just the same thing, guys. Nothing different. Are we together?
Yes, sir.
Yes.
Guys, there is this song. There is this song. I was there when they were recording it. It goes like I thought you guys are gonna join. I'm gonna start again. This choir is whack. Guys, I'm gonna start again. You're late. You can't chip in five business days later. I'm gonna start for the last time, guys. 1, 2, 3. You know what? Let's continue. This is not working. So now, guys, okay, let's focus on the chord. But remember, the chord and the arc, they work the same way. I'm working with the chord because I'm able to name it. It's easier to name the chord than to name the arc. But even the arc, guys, you can name it. You can say this is arc DC. Okay, but for now, let's focus on the chord, which is our guy on the left-hand side. So chord AB is doing something special. This guy is lucky. He's able to subtend an angle at the center, and also he's able to subtend an angle at the circumference. Do you see that?
Yes.
Okay, now we have a statement, guys. Remember, we have a statement and a conclusion. The conclusion is the one that is yet to be proved. Do you remember that from the first theorem we did? We have a statement, we have a conclusion. So what does the statement say? That is a fact. It's a fact because we see it, it's happening. There's nothing to prove there. It's something we see. Our statement says chord AB subtends subtends an angle at the center, and the angle at the circumference. So guys, when I was young, I used to live next to this Ethiopian guy. He had a shop. So I used to go there to wash his car. He will give me 10 rand to buy snacks, to buy 6 rand airtime so I can be able to see pictures on Facebook. Mind you, this was back when I was still young in 2017, when I was still very young. So I was always there because that guys will say, hey, my boy, clean the shop. I clean the shop, he gives me 15 rand. I wash the car, he gives me 10 rand. Maybe I wash his dishes, he give me 5 rand. There was a point whereby I was even able to sing his songs. Those are not South African songs. They're different songs. So the songs, they were like, hey, yeah. And I used to watch their movies, guys. I used to watch their movies. And when I watch the movie, I couldn't understand anything they're saying in the movie. I just see them crying. And if it's a lady and a guy, maybe I see, oh, these guys are in a relationship, that they're arguing. And when I see them arguing, guys, I haven't had the conversation. I don't know. And I blame the lady
So
always.
they are what?
That lady, why did he hurt the guy? Why can she do such a thing? Ladies are not good people. You see, guys, kind of thing. I was young. And I used to blame ladies, even though I couldn't hear the conversation. But when I see two people arguing, it's a guy and a lady, I blame the lady. Yeah, the lady did it. Whatever it is the lady's fault. So, guys, it was fun growing up. So this guy, now, it's a statement for this theorem. AB subtends an angle at the center and the angle at the circumference. Are we fine? Are we fine with the statements, guys? We can see it with our own naked bare eyes that indeed our chord AB subtends an angle beta at the center. It also subtends an angle alpha at the circumference. Are we fine?
Yes.
Okay.
Yes,
So now there comes a conclusion that we need to prove. So this conclusion, remember, guys, remember. The conclusion is here to be proved. We are not sure yet. Conclusion, guys, we are not sure until you prove it. But the moment you proven the condition, now it's like that forever because you proved it and you're sure. So we need to prove that the angle that is subtended by the same chord, the angle subtended by this same chord at the center is 2 times the angle subtended by the same chord at the circumference. So I'm just gonna write circum. Guys, circum is circumference. Circum in maths only means circumference. It doesn't mean anything else. It means circumference. Guys, I'm gonna emphasize circum in maths, it's circumference. Let me erase my things here. Well, Lily. These kids are dead. You guys are dead.
you went to that breakfast thing, ne?
Yes. Yeah, what?
You went.
What?
Did you go to the march?
Nah, I didn't go, unfortunately. I saw them singing passing by, but I was kind of being. I'm gonna go on the one on the 4th. We have a match. Go UJ campus on the 4th. I'm gonna go to that one. I have my shirt. There she do. It's a nice shirt.
Okay.
It's a nice shirt. Come think about it. Because she is collaborating with Flame, a clothing brand. Your tutors don't wanna buy. They want me to buy for them. But I understand, guys. And I'm supposed to be buying for my learners, not tutors. I get.
Yes.
I'm supposed to be
Yes.
buying for my siblings.
Those in matric, they can
But are
afford
not
themselves.
but not
Wow.
siblings, not siblings like Sambo and Fins. Nah, not those ones. Those ones
Oh
are
my
always
God. What?
when somebody they are always out to embarrass me. Okay, guys. So we are required to prove that. Okay, the statement says the statement, guys, which is something we can see that the chord subtends an angle at the center and the very same chord or the arc DC is the same thing. But now I said let's use chord AB. The same chord subtends an angle at the center and the same chord subtends a certain angle at the circumference. We see that's the statement. But now we say there is a conclusion that we yet to prove, which says the angle at the center is twice the angle at the circumference. We need to prove that. Can we do that? Let's do it. On the proof, because you see where the chord brings a line here, let's just use an arc. Guys, remember, both chord and arc, they work the same way. Don't be confused. Okay, now we are going to prove our theorem. Safa saphele sizwe semnyama.
Oh, Safa.
Oh, you are late, my sister.
Umanekile, son.
You're late. You are very late, my sister. Let me draw my circle here. Safa. Okay, guys, this thing angle at the center and the circumference, it can be like this. Maybe this is the center O and the very same arc at the circumference. Can you see the angle at the center and the angle at the circumference being subtended by the same arc? So it's not always gonna look like that. It can look like this. Also, it can look like this at the circumference and at the center O. You can see what here it's an arc here. Even if I draw a line, it becomes a chord. But if there's nothing, it's an arc. This Mansana, why is it scrolling? That's why do you see where we have an angle at the center and the very same arc it has the angle at the circumference? Let's call it scenario A. At the scenario B, you see we have an angle at the center and the very same arc subtends another angle at the circumference here. So do you see where this angle at the center, the circumference thing, how can it look like in different ways? Guys, it can also look like this, yes? It can look like this. This being the angle at the center, this being the angle at the circumference, which is the case here. No, it's supposed to be, oh, I'm sorry, this is not an arc. The arc is here. Let me use a different color. Sorry for confusing you. So sorry, I'm sorry. Oh, this, your arc is this. The angle that the arc makes at the center is this. The angle it makes at the circumference is this. Then here is your arc. The angle it makes at the center is this. The angle it makes at the circumference is this. So you'll see that more often with the examples and you must be able to recognize them. Guys, does everyone see it? Or I should draw bigger circles to show you, or do you see it?
Bigger circles with another
Oh.
explanation.
Oh, bigger circles, another explanation. Okay, ma'am. Actually, let me use the bigger circle I drew here. It's ugly. Look at this one. It looks like a graduation hair. It's a sign of you guys are gonna be successful.
Amen.
Let me draw. Okay, guys, did you understand the very first diagram I drew for the angle at the center and the circumference? You understood it, ne? First time it was like the, okay, this is my center O. First time it was like this. So I'm gonna use an arc this time, not a chord. At the center and at the circumference. So this is beta, this is alpha. Do you see already? Okay, let me use a different color pen, blue. Do you see already this arc? This arc, it subtends beta at the center and alpha at the circumference. At the circumference here, at the circumference. Do you see that, guys?
Yes.
Can everyone confirm? Either use a thumbs up or with your voice. Let me go to the call. Can everyone confirm? Use a thumbs up or a voice. Confirm, guys. Confirm.
Yes.
Yes.
Yes, sir.
Keep going. Let's do this for the last time. Safa saphelisizwa semnyama. I no. Lihle. Yekel. So you saw the first scenario, ne? So now we're gonna do this. Why is my circle gone, man? This thing loves scrolling to the top. I don't know what's up there. Hey, manje, my circle is messed up. Let me just throw in your circle. So I'm gonna draw my circle. So let's look at the second scenario. Then this is my center. Then the second scenario was like this. Okay, let's recognize our arc. This is our arc. Look at this. Let me use another color pen. Look at this, guys. This arc makes it subtend the second angle at the center. Now another look again. At the ends of the arc, there are also another lines. They are vying. They're meeting up at the circumference here. Or this same arc, it subtends another angle at the circumference. So now, do you see that, guys? Guys, do you see that? Guys, there is a last theorem we need to do. So, do you see that? Can you confirm with thumbs up that now you see the angle at the center and at the circumference? Okay, you guys confirmed it, thumbs up. So this is the second scenario. You have to be able to see it. So now let's look at the third one. Safa saphelisizwa semnyama. You guys are boring. So let me mark my points of the arc. So I'm gonna say
At this point, it's like you're singing for your rights. Can we have a break too?
no, the session is about to end because I'm only left with the theorem of the center. Then after the theorem of the center is done. So just give me
So
10
you
minutes.
see, when they stop answering you, say their brains are tired.
And you are right, because these theorems is gonna take a while. Okay, should I finish this theorem or we gonna just do it after the break?
So once we take a break, we won't come back. Let's just finish up.
You're right.
Definitely. Like that graduation headset room. My uncle never wore it because he took a gap year.
So let's do this. So this is my center O. Then I'm gonna do okay. I'm gonna do this. Okay, let's first recognize my arc. My arc is this. So now it's subtending the angle weirdly. You see how this is the angle at the center. Then this is the angle at the circumference. Do you see that? It's just now the angle is unusual. It's like this. You see? But this is still an angle. It just simply means the angle is greater than 180, guys. It's subtending an angle greater than 180. That's why it looks like that. Are we together, guys? Guys, are we together?
Yes.
That yes sounds tired, but okay.
Yeah, it's tired like the song you've been singing. It's tired of you singing it.
So
you can't sing.
I know, Ceci. That's why I'm singing struggle song.
Yeah.
I remember Rendelco Idols.
Why would you do that?
Rendel. Nka ba tshwere tlhogo no. They'd be asking me, what are you doing? You're tutoring. Please stick to tutoring. When they're about to quit, they ask you what you're doing in life. Let me bring this. Center O. Now we're going to prove the theorem. Now we know the statement and you know the different scenarios. So guys, my homework to you that you're going to submit before you sleep, I'm sorry for doing this. It will be proving with a different scenario of this. The scenarios I just showed. Now I'm going to prove it using this. How do you prove this? Let's say this is A, B, the center is O, then this is C here at the top. So how do you prove this? Remember, the first step, guys, you must do what you call construction. Ne? There is a mark for construction, meaning you have to redraw the diagram. So when it's like this, how do you prove? You need to construct the diameter. Remember there at the first theorem, you're constructing two radi so that you can have your, so you can complete right angle triangles. So here you need to complete triangles too. But what do? You construct a diameter. You're gonna construct it from up there. So I'm gonna use the red ink up there at C. So you're gonna construct it past O, which is the center, until at the bottom. So now please note, when you construct your diameter, your angle O and your angle C, they are being divided into two angles. So what I'll see, let me use black. It's gonna have, let me use a different color, not black. Let me use blue. I love blue. So I'm gonna say this is 1, this is C. This is C1, this is C2. This is supposed to be O. This is O1 and O2. Guys, are we together? Guys, are we together?
Unfortunately, yes, sir.
Unfortunately. Why are you saying unfortunately?
Yo, say, my brain is exploding right now. Like, yo.
Don't worry. The last theorem doesn't have a proof. So I'm just gonna explain it so that we are done. After proving this, I move to the next one. Then I'm gonna give you homework. Okay, guys, did you understand the construction and me allocating the angles? Because the diameter now divides these angles.
Yes, sir.
This is going to YouTube. No, this is going to YouTube. Someone just said, yo, my brain said, and now it's gonna be there on YouTube for probably my 15 years. So on YouTube, when someone is watching the video, a stranger somewhere, it's gonna hear you saying, yo, my brain said.
Say, TikTok level underscore mamsadi one.
Now, second thought, guys, I'm gonna edit this video for YouTube and crop out this part that Leo just said right now. Okay. So now if you understand, so guys, if you understood this, what I just did right now, so you understood the construction and me allocating O1, O2, and C1 and C2. So remember, what's the first statement? You say required to prove. What am I required to prove? That angle AO, you said you understood how to allocate angles. Angle AOB is equal to 2 times angle ACB. Guys, are we together? This is what you're required to prove. The angle at the center, the angle subtended by the arc or the chord. In this case, is the arc. The angle subtended by the arc at the center is 2 times the angle subtended by the same arc at the circumference. That's what you're required to prove, because remember, it's that conclusion we're required to prove. Are we together, guys?
Yes.
Okay, we did
As soon as
construction.
offenders start leaving the class, you just know it's bad.
Okay, let me be fast. Now, proof. Are you aware when we have two triangles? We have CAO and COB. And both triangles, guys, they have exterior angles, which is O1 and O2. Guys, are you aware that O1 is equals to angle A plus angle C? What's the proof? Exterior angle of triangle equals to the sum of interior opposite angles. Yes, interior opposite angles. Everyone knows this, ne? From grade 9. Exterior angle. This exterior angle, let me use this exterior angle of this triangle is equal to the sum of these interior opposite angles. Guys, are we fine? Guys, are we fine?
Okay, ngwana batho ho file thumbs up.
Oh, literally thumbs up. Guys, just confirm with your voice if even it's one of you, because I can't see the thumbs up. Okay.
Yes.
Guys, but are you aware that angle A is equal to angle C? Okay. Now, why are they equal? If you have a triangle, guys, and this side is equal to this side, their base angles are gonna be the same. Do you remember that?
Yes.
Okay. Are you sure, or you're just tired?
Nah, I
Okay.
didn't even hear what you said.
I know. That's what I'm asking. I answer.
Ah,
Kiri, do you remember if you have a triangle like this and these sides are equal, their base angles are also gonna be equal. The reason
what do
is
they call them?
angles opposite equal sides. When you write the reason, angles opposite equal sides. Do you remember that?
Yes,
Yes.
sir.
Yes, sir.
So now, check something. Are you aware or from the triangle that we are working with right now, the one with an O1, the one that I just took an exterior angle for? Are you aware that OA and OC, they are both radii of the same circle? They are both radii, are you aware? And radii of the same circle is always equal. Are you aware?
Yes.
Yes,
So
sir.
A equals to C1. Reason you write for that, you write angles opposite equal sides. We are done with this. Now let's go to the second triangle that has A2s, which is COB. This one. So let's go to that one. Yo, my siblings are hungry. Guys, if we're living together, I was gonna cook for you, yes? Papanyana with morogo there.
I know. Remember when you
When you
wanted
had it, you had it in the back and then you lost it.
I lost what?
So it's fine, just continue.
O2 is
That's
equals
what
to,
it
so O2 is equals to B plus C2. This one is the exterior, then the interior opposite angles is gonna be the B and the C2. Reason, what's the reason, guys? Exterior, so I'm just gonna write this. Exterior angle of a triangle equals to the sum of interior opposite angles. It's the reason I've written up here. Then same story, guys. My B is gonna be equals to C2. What's the reason? Same reason. Angles opposite equal sides. Perfect. Are we good now? So let me finish it here. Since for on the first one I said A equals to C1, so I can just say O1 is equals to. Are you aware, guys? Or I can just say where there is A, I can just put C1. Guys, if A equals to
No,
C1,
sir.
it means where there is A, I can just put C1. Anyway, here it's C1. So O1 is guys, are we together?
Yes, sir.
So let me do this. Guys, I'm also tired. Like we had a 1 hour, 30 minutes class, guys. It's not a joke. I know, guys, but it's worth it. Remember, success comes to those who sit in class for a long time. So
You should consider being a
I shouldn't have.
motivational speaker.
That is so real.
So where there's since A and C1 are the same, I can just where there's A, I can put C1. So it's C1 plus C1. So I can say O1 is equals to twice C1. Fine. Same story with O2. Since B equals to C2, where there's B, I can put C2. C2 plus C2 is equals to, what is gonna be twice C2. Are we fine, guys? Guys, are we fine?
Yes, sir. Yeah, bro.
Are we fine?
So, yeah.
So now let's add O1. Last step, you add O1 plus O2. It's equals to O1 plus O2 is equals to 2C1 plus 2C2. So therefore, 2O2 is equals to 2 into C1 plus C2. Therefore, O1 plus O2, no, it's not 2O2, I'm sorry. O1 plus O2 is just O because it was O like halved into two parts, which is O1, O2, just makes O. So O is equals to C1 plus 2 plus C2, it's C, so it's twice C. We proved, guys, our angle at the center is twice the angle at the circumference, which your O is AOB, then your C is ACB, angle ACB. Are we fine, guys?
Yes, sir.
So you can conclude that therefore angle AOB is indeed twice angle ACB.
And we're done.
Are we fine, guys? Yes, we are done. You are not focusing, ne?
Guys, I have something for you, Mamela.
So, guys, now you can approve this one. Let me erase this
From you, we are
stuff so
not
that I can
done.
send a picture.
Really? What? I
No,
thought
we are
we're
not done. We are left with one theorem. This one, guys, no proving this one. It's not proving
Didn't you
this
say
one.
that
There's no.
was the first one?
So the last theorem, guys, when it comes to
Yeah.
the last theorem, when it comes to center, to theorems of the center is this one. If you have a circle, you have center O. Now, guys, listen to me. You have a special chord. The one that I was talking about saying is special, is drawn from one point of the circumference, passes through the center to the other point of the circumference. What's the name of this guy, Gonje? Hibanna. Guys, don't embarrass me. What's the name of diameter? Yeah. So if this guy subtends an angle at the circumference, we are saying that angle is therefore equals to 90 degrees. Guys, the theorem is done like this. If a chord subtend, so guys, if you have this situation, this is the center O, and you have the diameter, the special chord, it subtends an angle here. This is not at the circumference, that's not 90. So, but if my diameter subtends a certain angle at the circumference, then that angle is 90 degrees, guys. Are we fine?
Yes, sir.
Okay, guys. I know you are tired, hence I was a bit fast. Homework. Go and... Okay, by the way, guys, okay, let me do this. Shower, follow, yo. That Valo song, I don't know why people are obsessed with it because wow. So O is the center. O is the center. So question, prove that AOB is equals to twice ACB. Out of 6 marks, out of 7 marks, don't forget your construction, ne? Guys, don't forget your construction, ne?
Yes.
Okay, so
Bye.
Anyway, guys, wait, guys, this is the end of our first. This is the end of our first Euclidean geometry session. This is part 1. Guys, the reason I don't want to be fast to rush to finish the topic, because remember, I'm hosting these classes for you to understand. So this is not for race. Even if it takes me 5 weeks to finish the topic, it's fine. By the way, it's gonna take me 2 days now. Let me see that one. So guys, the purpose of this is to help you understand. You cannot do it in class, or you cannot do it with your tutors. I saw on our way for grade 11, he was doing it Euclidean. So this is just gonna provide you with like an extra, you understand. I know now you understand most of the things if you did the topic before. If you're doing it for the first time, no problem. Grade 12s, you're not seeing this for the first time, but I know you didn't understand some things in the past. Fine. Now it's time to clear the whatever that you didn't understand, to make sure now it was the time to make sure that you understand it. Ne? So guys, the video will be available for you in 2 minutes. If you want to watch it again sometime. This is part 1. I'm going to see you for part 2 tomorrow. Hopefully part 2, part 3.
Against Uwana's idea of becoming a motivational speaker. Uthonzana ube mfundisi, say, yo, you love preaching.
Sambotoswa. Otoswa.
No, sir.
Nebo. Mkhuze.
Se.
Mkhuze.
Ngeke ngimkhuze mina ngiyolala.
Waona nako ukhuza nalabo sam. Okay guys. Bye-bye.
Bye.
Guys, I'm gonna send the notes with the back. Bye.
Se go batla ning homework?
Before Rowan.
Yo.
Kawusani, bye.
No, before
So-
Rowan.
So what about
Yes.
us, ne? If ngalali, some of us who don't sleep, like literally.
You don't sleep.
Yes.
Rata boroko ne?
Yeah, we
Njani manje?
go.
Why can't you see?
Like around
Why can't
Boma
we-
2-3.
No, literally. Like I finished studying at 4 and then I started preparing for school.
No, that's not healthy. Please, that's not healthy.